Hello, beautiful people, and welcome. In this video, we are talking about triangle inequalities. Now, this comes from the triangle inequality theorem that says the sum of any two side lengths of a triangle is greater than the third side. So what the heck does that mean? So that means let's take a triangle. Let's go ahead and actually get this out of the way. Let's say we have a triangle. Trying not to blind you here. This is an equilateral triangle. That means all sides, all angles are the same here. And we can see that it forms a triangle. So what that means is if we have the sum of any two of these, it's always going to be larger than that third side. So let's switch this up. Let's do that. Still larger. Let's do that, still larger. So any sort of combination of two sides is always going to be larger than the third. Now, we can also do this where it doesn't work. For example, if I have something like this, I can, take a look. I can do it. If I can scooch this forward, this still works. Let's see if we can do another one. Just going to break this down. Let's see where the theorem fails. If I add these two up, this is almost, but not quite, smaller. Do you see how it's smaller than that third side? So because the addition of these two sides is smaller than the addition of that third side, that means no matter how I try this, I can't form an actual triangle with these three sides. Like I'm trying, don't get me wrong, I'm trying. It just won't happen. There's always going to be some sort of gap, and that gap comes from these two being smaller than that third side. So let's see this application. The triangle inequality theorem states that these two sides, so this side and this side added together is greater than that third side. These two sides greater than that third side, and the third here greater than that third side. We also have side angle relationships and angle side relationships in triangles. So what that means is if two sides of a triangle are not congruent, then the longer side is opposite the longer angle, and the larger angle is opposite the longer side. What that means is if this angle is the medium angle, I'll do M for medium, then this side here is the medium side. If this angle is the smallest angle, I'll put S here, then the opposite side here, that's the smallest side. And if this guy right here, this B, is the largest angle, I'll put an L here, that means this opposite side is the largest side. Now it also works if the side is the largest, then this is the largest angle, this is the middle angle, then this is the middle side, but it's always opposite of what you see. So opposite, opposite, opposite. And if you're struggling, which one's the opposite? Always start with one of the pointier ones. Here, the larger angle, and you can see easier where the opposites are. All right, let's go ahead and do some examples. Write the angles of triangle DEF in order from smallest to largest. Okay, so how do we do this? Well, let's choose which one's the smallest side. This is the smallest side, so that means 2 is the middle side. And I'm looking at the distance, right? The size of it. That means 2 1/8 is the largest side. So what I meant earlier by I said choose like the largest, it's easier to see the largest than go across the street from the largest. So if 2 1/8 is the largest side, that means E is the largest angle. Then you can see that the smallest side is across the smallest angle, and the middle side is across from the middle angle. So let's go ahead and list the angles from smallest to largest. So smallest two largest. So the smallest angle we have is angle F. The middle angle we have is angle D. And then the largest angle we have is angle E. Moving on to example number 2. It's asking us, can 3 segments, one of them being 8, the second is 15, and the 13 is 6, make a triangle? So this is coming from the triangle inequality theorem. Let's write that down. And that means that if I take any combination, so 8 and 15, 8 and 6, 15 and 6, all 3 different combinations, if I take that, all of these added together, all 3 of these, need to be greater than the third side. So if I take 8 plus 15, it needs to be greater than 6. If I take 8 plus 6, it needs to be greater than 15. If I take 15 plus 6, it needs to be greater than 8. So is 8 plus 15 greater than 6? No, this is false. Is 8 plus 6 greater than 15? Well, let's check. 8 plus 6, oops. That is 14. That is also false. 15 plus 6 is not greater than 18. This is false. So you only need one. Yes, all 3 were false statements, but you only need one. So at least one inequality fails. So, no, you cannot make a triangle. All right, let's go and move on to question number 3. Find the range of possible values for x using the triangle inequality theorem. So that means we're going to set up 3 different types of equations. We're going to have x plus 3, we're going to have x plus 8, and we're going to have 8 plus 3. Now again, the summation, the adding of the 2 sides needs to be greater than that third side. So what's the third side? If I use 8 and 3, if I use x and 3, it needs to be greater than 8. If I use x and 8, it needs to be greater than 3. And if I use 8 plus 3, that needs to be greater than x. And so what we do is we're actually solving for x as if it were just a regular equation. So I'm going to subtract 3, x is then greater than 5. I'm going to subtract 8, x is then greater than negative 5, and 8, 9, 10, 11 is x. Now, we have 3 values that x could potentially be. That's weird. That's weird. So what's going to happen is you're looking for your answer to make sense. You're looking for your answer to make sense. For example, distance cannot be negative. You can only travel. You can't undo travel. You can come back by traveling, but you can't undo travel. So that means this x being negative 5, that's a false statement. This cannot be negative. Now we have 2. Looking back at the instructions, at the directions, it says find the range. So that means they're not looking for one value. They're looking for what's the smallest and what's the largest x can be. So your answer is going to look something like this. You're going to take the smaller number that's positive, in this case 5. You're going to write x, and then you're going to take the larger number 11. And then you're going to write these symbols, less than, less than. And what that means is 5 is less than x, but x is less than 11. So that means x has to be bigger than 5, x has to be bigger, x has to be bigger than 5, and x has to be smaller than 11 in order for us to build a triangle. Moving on to question number 4. Can a triangle be formed? So very similar to question number 2. Let's check. We're going to take two sides, add them. Take two sides, add them. Take two sides, add them. Which one am I missing? I am missing 30. And these need to be greater than that third side. So 24, 8 needs to be greater than 30. 24, 30 needs to be greater than 8. And immediately this one I know fails. 8 and 30 needs to be greater than 24. So because this one fails, the answer is no. So can you form a triangle? No, you cannot. All right, let's go ahead and move on to the next one. Find the range of values for x. So very similarly to example number, number 3, 4, 3. We're going to set up 3 different equations. So we have 18 plus 9. You have 9 plus x, and we have 18 plus x. All of them are greater than that third side. So in this case, x, in this case, 18, and in this case, 9. We're going to solve this as if it were an equation. So 18 plus 9, that is 27. So I have 27 greater than x. Here, I have minus 9 minus 9. So x is equal to positive 9. Oop, not equal to, greater than. And here I have minus 18 minus 18. X is then greater than negative 9. Immediately when you see that negative number, that means it's not an option, so you cannot be negative. And then we're going to write our range. So we're going to take the smaller number, which is 9. We're going to write x, and we're going to write 27. And then we're going to say 9 is smaller than x. However, x is smaller than 27. And this is our range. Last question. List the sides of triangle ABC from least to greatest. So we want the sides. So it looks like we're going to be using that side angle, angle side relationship in triangles. So that means this is our smallest, this is our largest, this is our middle, and they're always opposite. And again, I like to start from the largest and go across the street because that's going to give me my largest side. After that, it's a little bit easier to see which one's the smallest and which one's the middle. So since we want sides from smallest, least, to greatest, we're doing segments. Segment, which one's the smallest? Smallest is segment CB or BC. Then we have, this is less than. Then we have our middle, which is segment AB. And then we have our largest, which is segment either CA or AC. Doesn't really matter the order. That is it. All right, beautiful people, thank you so much for watching my video, and I will see you in the next one. Bye.